I like to sort of archive these lectures. That way, if you guys ever want to go back and have a look at them and review anything that we do or anything that we talked about, you can certainly do that. Those are going to be over at my YouTube page. I think I actually have links there in my syllabus to get to it. If that's a problem, just let me know. I can get that info to you. All right, so I'm going to do a screen share here. Okay, and I kind of sort of need to remember where I put my syllabus. I think it's here in my files. Okay, there it is. Everybody see that okay?
Yep.
Okay, excellent. Thank you. All right, so just a few things as we work through this, and then hopefully at the end we'll have some time to take a few questions if you need, and then actually get into a little bit of note taking today. So quantitative analysis, that's the name of the course, spring 2021. My instructor information is here. So the easiest way to get in touch with me, since we're going to be virtual and remote much of the time, is through email. I'm generally pretty quick to respond to email. I'm generally checking it on an hourly basis. So, hold your horses a little bit, but if you haven't heard from me in, a few hours, you could certainly get back to me. But generally, I'm pretty quick to get back to those. My office is FSC 303. It's down next to Dr. Kagris's office. If you happen to need to get down to see me for anything. So it's on that opposite end of the building from where the labs are. And my office hours are shown there. Now, those are the Zoom links that will take you in. So each office hour has its own Zoom link. So be aware of that. Okay, so make sure you're getting on the right link to get to the right office hour on the correct day if you need me. We will be using a text in here. It's Harris Exploring Chemical Analysis. Make sure you get the 5th edition. I think most people go for the e-text on this. I found a link or two to it. It's anywhere, depending on who you buy it from, $20 to $25. That's what most folks do. You can also, I think, get hard copies. I believe the bookstore actually has some. I had them order some. So either hard copy or electronic, whichever way you want to go with that. Grab that as soon as you can, though, because we are going to be relying on it pretty much from the get-go. Meeting times, the lectures Monday, Wednesday, 3:30 to 4:20. We'll be doing that part remotely. And I leave you a Zoom link there. Everybody got in, you got the Zoom invite. So make sure you bookmark that so you can get back in whenever you need to. And the link is there if you need it. Lab is going to be Tuesday, and it got moved to the evenings. We always do this normally as an 8 in the morning lab, but since we had to condense down into one lab section, I think the only time Dr. McCann could find to get everybody there was 5 o'clock to 7:45 in the evening. And we're going to be down in FSC 328. So if you had majors lab last semester, it's the same room down by the organic lab. Okay. Class schedule is shown here. These are going to be the labs we're going to do and basically when we're going to do them. The difference you're going to find here for a lot of these labs is that we have some multi-week labs. I think generally when you're in that first semester lab, and I may be wrong about this, I've never taught it, most labs probably go for a week and then you turn in a lab report at the end of each week. In this case, notice, for example, the gravimetric determination of calcium. That's the second lab we do. That's a 3-week lab. So I won't actually take up any notebooks until you get to the end of it. So you'll have a 3-week stint there where you won't owe me a notebook, okay? So basically what happens is in the week you finish a lab, you'll write it up in the week subsequent to that, and then the very next week at lab, you'll hand me your yellow pages. Now that's another thing I've decided to do just to keep things easy and simple, is that all written work we're gonna do will be done or turned in on a lab period. So anything and everything that's going to be due will always be due on a Tuesday, okay? So whether it's a homework assignment, lab pages, or quizzes, all of that will be done on Tuesdays, and it'll all be hard copy. So I'll hand you a piece of paper, or you'll hand me paper back. So there won't be any exchanges of e-files or anything like that. Like for homework though, I'll post that up on D2L so you can go find it. But when you do it, you're going to present it to me as a hard copy. Okay, so anything that comes to me will come to me as actual paper. That way it's easier for me to write comments on it and get it back to you. Whatever you hand me on a given Tuesday will all come back to you the next Tuesday. Okay, so batch in, batch out, basically. By the way, that first homework assignment I mentioned, I did post that up to D2L. It's shown there under the announcements. So it's already posted and ready for you guys to go, but we'll talk about that a little later. All right, so essentially what we're going to start with in week 1, which is tomorrow, is we're going to do the check-in. So we're going to go in, we're going to make sure that all the drawers are up to date. Everybody's got all the gear they need. And that'll get us ready for the second week, which is calibration of a 50 milliliter burette. And the procedure for that's actually in your textbook, but I'm going to copy it out and post it up on D2L for you guys. So in case you don't have a textbook, you can find it. So it'll be up there probably as of tomorrow. All right, so that's basically what we're looking at. Notice also on week 15, we have a final exam. That's a written final that we'll actually take. So that's a face-to-face written final. I assume it'll be face-to-face unless they end up having us do otherwise. Then I think last year I ended up giving it electronically, but we'll find out what to do about that when the time comes. All right, as far as attendance goes, everybody has to do their own individual lab work. So you can't just pair up and do stuff in pairs. You can help each other, talk to each other, that's fine, but each individual person has to do their own work. If you happen to be absent due to illness or anything of that nature, especially in times of COVID here, you never know what might happen. We try to get you to make up those labs. If it turns out that you're out for an extended period of time due to COVID, we have other ways of dealing with that. So we'll talk together at that situation and deal with it. If you get a snowy night or something like that, where I'm coming from Hagerstown and it turns out I can't get there, I'll let you know in advance and we'll figure out how to proceed from there. So if we have a snow day or something like that, I'll keep you informed on what we're going to do. Chances are we're going to try to make that lab up at some point. That's normally how we would do it. All right. I would let you know, so we'd be in touch about that. As far as homework goes, there will be some graded homework in here. Normally, but not always, about an assignment per week. So basically, I would assign that out to you on D2L. And then if there's a homework assignment due, it'll be due at the beginning of lab on Tuesday when you come in. So one of the first things you'll do when you come in on a Tuesday is hand me anything you owe me. So that could be a homework assignment, could be yellow pages from your labs if you have a lab due. Then the other thing, of course, we'll do is take a quiz. Okay. Lab notebooks, they're going to be due exactly 1 week after the lab is completed. So again, that means a whole lab is completed. You'll have a week to write it up, ask questions, do the calculations, whatever you have to do. And then you're going to hand it to me the following Tuesday. Okay, so you finish a lab on one Tuesday, you're going to hand it to me, the yellow pages, the next Tuesday. All right, as far as late work goes, 5 points deducted per day late. And I do pay very close attention to that. Now, we also mentioned quizzes. We're going to give a quiz once a week normally, and we do it at the very beginning of lab. So we would take the first maybe 15, 20 minutes of lab time to actually take a quiz. All right, now what would be on a quiz? Well, a quiz can involve stuff that you do in the lab, but remember we also have a lecture component to the course where we're going through background type things that are important to the lab. In many ways, the lecture will actually also mirror what you're doing at different times in the dynamics course. So that information is fair game for the quiz as well. So make sure you're keeping up with your homework, make sure you're keeping up with the lecture content and also the lab content. So any and all of those things can show up in the quizzes. All right. If you happen to not show up for lab to take a quiz, we don't do makeups unless, for example, you are out for an excused reason such as illness. Okay. But if you show up 30 minutes late for lab, no, you can't take the quiz. That's really what we're talking about here. All right, as far as grading goes, several categories of grades that we're going to be looking at. The first is quantitative results. Now, what this deals with is sort of the basis of the course. Some, but not all of the labs that you're going to do are going to have quantitative results associated with them. So basically, I'm going to give you an unknown. the job of the quant lab, or your job in the quant lab, is to actually determine the concentration or amount of analyte or some substance in that unknown. And you're going to hand me a number based upon an average, and you're going to give me some statistical data. For example, you'll also hand me a standard deviation. Okay. You're going to be assessed based on your accuracy and precision of results. In other words, you got to get the right answer or get somewhere close to it. And I'm also going to be grading you on how close together your individual trials are to each other. So your accuracy and precision scores, and we'll talk about that more when we actually get to it, get combined into that quantitative results score. Okay, so that turns out to be 20% of your grade. Used to be a lot more, but I notched it back because not as many of the labs that we do now have quant scores attached to them. You'll know in advance if they do or don't. A big factor is, of course, the lab notebook that you're going to keep. That's going to be 30% of your grade. Those are your yellow sheets that you're going to hand to me the week after you finish your lab. Assigned homework, 10%. So whenever homework's due, I'm going to take it up and I'm going to look it over and grade it. And then it'll get returned to you with a grade on it. So that's where that grade component comes from. Quizzes, 25%. We already talked a little bit about what's on a quiz and what it comprises. We're probably going to do either a formal report or some section of a formal report at some point during the semester. So that turns out to be 5%. And then you got a written final exam during exam week. That's going to be 10%. Okay, so hopefully all that stuff adds up to 100% if I did my math right. Okay, any questions so far, guys?
As for grading, what scale will you use?
I think I actually put that down there. I hope I did. No, I guess I didn't. It's sort of the normal scale that I would use anywhere else. It's sort of the same as the lecture scale. It's like 87.5% or better is an A. It's like 75% or better turns out to be the B. Same as a lecture scale. As it turns out, sometimes I end up moving those things around a little bit, but those would be more or less the guaranteed grades. But more or less the same as like the lecture scale that you would look at. That's kind of used universally in our department. I thought I stuck it there, but I guess I didn't. But that's what I do. And those would be guaranteed grades. Like I said, I can lower those bars a little bit if I need to. Basically, I just want to make sure the distribution turns out to be something that I like and I consider fair. All right. Lab notebook guidelines. So basically, I'm not going to spend a lot of time here because you guys pretty much have all been in the first semester lab, and some of you have actually been in many labs because you're upperclassmen. So basically, you're going to hand me the yellow sheets, which are your duplicate sheets, and I'm going to be looking for the standard kinds of things that you normally would see, okay? So again, I talk about late reports, 5 points deducted per day. We talked about that before. And then just a few other things. Data and observations, as you know, need to be directly written into the notebook in ink. And I can tell whether it's ink or not, even though you're handing me your yellow sheets, which are your duplicate sheets. And one big thing is you don't want to write your data down on a piece of paper and then copy it into the notebook later on, because often what happens is you lose the piece of paper and that ends up not happening. Okay. Also, how do you deal with edits or mistakes? Well, you would actually use either an X for something large, or if you're talking about a single word or number, just a single strike through. And you can see that's just a line written through the number or the word. Okay. Also, keep track of your table of contents. That's important. And follow the format. Now, basically, this format down here is essentially the very same format that you would see in any lab. So I'm guessing this is pretty much more or less the same format that you used last semester. Okay, so for the most part, I'm not horribly picky about this. I just need to make sure the parts are there. Okay, so I'm looking for a title. I'm looking for a statement of purpose. I'm looking for a procedure. Now, of course, those three things are always done before you come to lab, right? And the most important part of that procedure, of course, is that you take the written procedure that I give you and you need to paraphrase it into your own words. And I like it either as a numbered or bulleted list of things you have to do, okay? So that way you can kind of check them off as you go to make sure that you actually did them. All right, so that's normally what I like to see in a procedure. So I don't want you to take whatever procedure I give you and copy it verbatim into your notebook. Bullet it out, put it in your own words, think about it a little bit. Okay? Then the rest of the stuff you do in the lab. The data and the observations. Two types of data and observations. The first is qualitative. And again, I'm sure you guys did this last semester. Those are any things that you notice about the reagent. So you always want to write down the observations about the reagent. So you might, for example, list the state of the chemical reagent. So if you're talking about water, you would say it's a clear, colorless liquid. Okay, so you're telling me the state. You're also telling me about its appearance. You might even tell me it's odorless. Okay, so these would be all observations you're making about reagents. The other type of observation, which is of a qualitative nature, of course, is any sort of chemical change that you see. Okay, so you see a color change, or you see a precipitate form, or color develop inside of a supernatant or something like that. You're going to tell me about that. Okay, so those are all qualitative observations. Those don't have numbers attached to them. These are basically observations that you're making because of something you see. Okay. Now, the other type of observation, of course, is the quantitative observations. So those are the ones that have numbers and units attached to them. And of course, those are the ones you're going to use primarily when you do your calculations. So what students often tend to do is forget to put a complete comprehensive set of qualitative observations in. They have the quantitative stuff there. You have to have it because you're not doing your calculations without it. Okay, but people tend to forget the qualitative part. So make sure you're writing those things down as well. And if I catch you not doing it, I'll remind you. Then you've got the calculation section. Okay, so these are manipulations of the quantitative data that you recorded that you're going to do. Okay, so your procedures are going to be fairly forthright in terms of what you're being asked to calculate from your quantitative observations. But what I need to see there is at least one full calculation start to finish for one trial. Okay, that has to be there so I can track what you're doing. Finally, the results section, that's going to be a table that summarizes the results of your calculations along with the appropriate statistics. And normally that's going to be a mean, a standard deviation, and a 95% confidence limit. And we're going to talk about all that in the lecture so you'll know what it is. Okay, so compile that all into a table, and those are going to be your results. Finally, you've got your conclusions, and that's a short summary of the lab and what you did. So what were the primary things you did? What were the primary things you learned? What was the primary take home from the lab? The other thing I like to see there is just sort of a qualitative error analysis. Since we're really focusing in the quant lab on technique, it's a really technique-based lab. We really pay attention to error. So this is what you guys kind of like to term human error, if you will. So we're trying to kind of minimize that, okay? So this is where we go back and think about possible mistakes we could have made in the lab and what effect those mistakes would have had on the final outcome of the lab. So I generally ask you to give me 3 specific sources of error that could have happened. And don't say calculation error or human error. I need you to be a lot more specific than that, okay? And you'll see what I mean when we actually start getting into the labs and I start reminding you of things that you need to be careful of. And then finally, you want to do a signature and date at the bottom of the page after the conclusion sections. Normally, I won't have any kind of post-lab questions. There may be a lab or two where I do ask a few. And if I do, those are taken care of under the conclusion section. Okay, so again, title, purpose, and procedure are done before you come to lab. And sometimes I may wander about in the lab and make sure you've got those, okay? And if you don't, I might send you out to do them before you can come back in the lab. All right, and like I said, your graded lab report pages are going to get returned to you at the next lab meeting. So you hand them to me on one Tuesday, you get it all back the next Tuesday. Then finally, the Title IX language, which we're required to put in our syllabi, which you can read through. And this talks about what constitutes sexual harassment and how to report it primarily. All right, so questions about the syllabus, guys?
For the lab report, do you want like a materials section or not?
Well, you can. If you're used to putting that in, that's perfectly okay. I don't require it. I know some professors like to see materials. Sometimes you'll see like methods and materials or something like that. And that kind of falls like under procedural stuff. So if you want to add that in, you're perfectly fine adding that into the procedural section or as an addendum to that if you would like. I don't require it, but if you find it helpful, you're certainly able to do that. It's not something I would ever take off for, in other words.
Okay, thank you.
No problem. Any others, guys?
For multi-day labs like the gravimetric determination of calcium, I noticed that the observations and data sheet said that it must be dated. So would we do the date for the one, date that sheet, do calculations for that day after it, and then put data for the next lab after that? Or should we like partition 3 pages off for all of our data and then do the calculations all at the end?
I'll tell you what, I've seen students do it both ways, and I'm perfectly fine with either way. Sometimes you actually need to have the results of the calculations from one day to move forward in the next day. So what I sometimes see students do is in a particular day, they'll put all their observations and their numbers down, and then they'll put a calculation section for that day after it and show the calculations and date it. Then when they come in the lab the next time, they'll put another data and observation section in, followed by a second calculation section for that day. So if it makes sense for you to do it that way, that's perfectly okay by me. Some people prefer to do it the other way and lump all their data and observations into one place and all their calculations into one place. I'm fine either way. But I know some students don't like to say, okay, well, how much space am I going to need to sort of work ahead in my notebook without wasting pages? So in that sense, the former kind of sort of makes more sense to me. But honestly, as long as the sections are there, you're fine to do it either way. Does that answer your question, sort of? I'm showing you I'm giving you a lot of latitude here is basically.
Yeah, no, that answers my question. You're basically saying we can do what we want as long as it's organized.
As long as it's organized and I can follow it. You got it. Well put. Other questions, guys? Okay, so I think this is all posted out at D2L. So if you need to go grab it, it'll be over at D2L. There's probably some other stuff I'll post there, for example, like the safety sheet, which we're going to go over, as well as the drawer list, which we'll go over tomorrow. I'll hand you hard copies of those things as we check in tomorrow. All right, so that should get us ready for what we need to do tomorrow, basically, which is come to lab and meet at 5. And we're going to go on through our drawers and make sure that we're all ready to start with the first lab the next week. Okay, let me pop out of here, guys. And I'm going to go over to my notes here. And basically what I like to do here is I like to work through my lecture notes pretty much as I would at the chalkboard. Okay, so this is kind of my chalk talk that I do. And this is the closest thing I've been able to find to doing that, which is basically just taking notes on my iPad and just having you guys follow along and write down notes, just like you're watching me work at a chalkboard. Okay, so I think it actually works out pretty well. Sometimes I might write these out a little bit skeletally, so I'll have some stuff written down here in advance to kind of remind me what I'm doing, or if I'm doing an example problem or something like that, I'll probably write the problem out in advance. Okay, so let's go ahead and get started. So starting today, let's just talk a little bit about the course in general and what quantitative analysis is all about. Okay, so we kind of short term that as quant. We talk about the quant lab or the quant course. Okay, so what we're dealing with is we're looking at certain types of observations. Okay, so if we're looking at observations in the lab, we already kind of touched on this in the syllabus. Observations can either be of a non-quantitative or otherwise qualitative type, which are things like we said, color changes, observation of the formation of a precipitate, a gas being evolved, something like that. Then the other kind of measurement we can make or observation we can make is going to be a quantitative observation. Okay, so anytime we're talking about a quantitative observation of measurement, we're going to see that we're going to be looking at a number plus a unit, okay? Now, I don't need to insult you guys' intelligence to explain why you have a unit attached to a number. You guys all know why that has to be the case. Unit tells me, of course, what we're measuring. It tells me about the scale of the measurement, right? So if I make a measurement of 125 centimeters, okay, that tells me I'm measuring a length or a distance, and the centimeter part tells me the scale of the measurement, okay? So a number is meaningless by itself. It needs a unit attached to it to give it the meaning that we need for it to have in the lab or to work a problem or whatever it is we're trying to do. So the quant part is the measurement part. We're actually making numerical measurements of things, okay? Now, primarily what we're talking about here in a quantitative measurement in our lab is an amount of an analyte present in a sample. Okay, so I might hand you an unknown sample, all right, and I might ask you to tell me how many milligrams of calcium are in the sample. Okay, so the analyte, of course, is going to be that component of interest. That's what I'm asking you to measure. All right, so in other words, just the focus of our measurement. Okay, so like I said, I could give you an aqueous sample, and I could ask you how many milligrams or micrograms of calcium are present in that aqueous sample. Now, generally when I do that, when you have something that's part of a mixture like that, and the analyte is just one component of the mixture, and usually it's going to be a liquid solution, the best way to report this out is by means of concentration, right? So that's something we're always going to come back to. So in terms of concentration, we're always interested in expressing the amount of analyte that we have per total either mass or volume of the sample that I give you, okay? So what are some typical units of concentration that you guys have talked about, say in lab or lecture up to this point? What's a typical one? Somebody want to just throw one out at me?
Grams per milliliter or liter.
Okay, so a concentration could be in terms of grams. Let's put analyte here. And let's say per liter of, how about solution? Would that be okay? Yeah. I mean, that would be a perfectly acceptable unit of concentration. It's probably not the one we use most often, but it's perfectly acceptable. Okay, what's another one? That's certainly one option.
Percent mass.
Okay, that's a good one. What's another one? What's the big one I know you guys talked about in bonding?
Molarity.
Molarity, very good. That's the big M one, right? Yep, very good. There's a couple others. I'll just mention down here as item number 4. If you can have a percent by mass, you could also have a percent by volume. That's another one that might be of use. There's another one here that we sometimes use in the quant lab, and we'll kind of come back and talk about these individually. It's called the part per million, or ppm. This is one that we often use if we're talking about a very dilute solution of a given analyte. Did you guys ever do parts per million back in bonding? Some of you may, some of you may not have.
No,
No
I don't
big
think
deal
so.
if you didn't. It's a new one for us. Okay. So let's just go back and kind of look at these from 2 on down. Like I said, number 1 is perfectly acceptable, but it's not a typical one that we would use. A percent by mass. How would I define that? What's a percent by mass in terms of my analyte and, say, my solution? What would be the best way to define it?
Mass of analyte over mass of solution total.
Yeah, that sounds good. Okay. Now, we could use any mass unit we want here. We'll just say grams over grams. That's just typical because we use grams. Could be kilograms over kilograms or milligrams over milligrams, but grams are typical, so that's what we use. How do I turn it in? This is a mass ratio now. How do I turn it into a percent?
Multiply by 100.
Yeah, multiply by 100. And I'll just stick the percent there so we remind ourselves that we're turning it into a percent. Now, if we do a percent volume, and we'll actually, I think in one of the labs end up doing a percent volume. I haven't actually vetted the lab yet, but if we actually get to it, I think this is how we'll end up doing this just because it's the proper way for that specific measurement. Now, how would I do a percent by volume? What would that be? And I'll give you a hint. This is often a case where I have a situation where both the solute and the solvent are liquids. And the solution obviously would be a liquid. It would be kind of the same thing as a percent by mass, but now we use volume units. So it would be the volume of the analyte, say milliliters, because that's a good volume unit, divided by the volume of the solution, total solution, right? And that would also be in milliliters, if we want to use that, times 100%. So for example, we're going to be looking at a volume percent of ethyl alcohol in a mixture. And if you're talking about, for example, brewed beverages such as beer, wine, kombucha, that kind of stuff, we're going to look at kombucha. It turns out that we use a percent by volume to talk about alcohol content. So that's why we're going to use that one. All right, so molarity. How about molarity? Anybody remember the definition of that?
Moles per liter of solution.
Okay, yeah, that's exactly right. It's going to be moles of analyte per liters of total solution. Okay, moles per liter. Okay, very good. Parts per million. Again, that's the one that's probably going to be a little different from you guys. So it's usually done almost as a mass ratio. It's kind of like a percent by mass in a sense, okay, where we're talking about essentially the mass of the analyte, okay, per million parts by mass of the solution. It's one. So in other words, if I've got a 1 part per million solution, it could be, for example, let's just put it here, 1 microgram of analyte per 10 to the 6 of the same unit of total solution. Okay, so it's kind of like a mass ratio that way. Now, notice that's 1 part per 1 million parts whole, right? Because there's 10 to the 6 micrograms. So I'm talking about 1 part in 1 million, 1 microgram per 10 to the 6 micrograms. By the way, what's another term for 10 to the 6 micrograms? What's another way I could express that in terms of a mass?
1 gram.
You got it. 1 gram is the same thing as 10 to the 6 micrograms. So in many cases, we would express a part per million as 1 microgram of analyte per gram of solution. Okay? So it's still a mass ratio, just like a percent by mass is. But this one's really nice to use if you're talking about a very, very dilute solution. So something that doesn't have a whole lot of analyte present. Okay, so if I had something that's 25 parts per million, okay, that's 25 micrograms of the analyte per gram whole of the sample. Okay, so that's not a whole lot of analyte in that case. So we're starting to talk about trace analysis when we get to this point. Another way you could express it is in terms of milligrams of analyte per kilogram of solution. I'll call it sample or solution or whatever we want to call it. All right. Now, there's another way to do this as well. If you're doing a dilute solution, dilute aqueous solution, which is generally what we're dealing with in the quant lab, another way to express parts per million is micrograms of my analyte per milliliter of sample or solution. Now, why can I get away with that if I'm talking about a dilute aqueous solution? Well, it's because of the density, right? The density of H2O is approximately 1 gram per milliliter, right? So I can exchange a milliliter in for a gram in my denominator there, and I'll be just fine because of the density of water. Now, if I have a very dilute solution, I'm going to make the assumption that the density of the solution is going to be the same as that of water, and I can get away with this. The other way I could talk about this would be in terms of a milligram of analyte, looking at my second definition there, per liter of solution, right? Because again, a liter of solution would have a mass of a kilogram. All right, so that's how I'm going to express part per million. And that's, again, another concentration unit we're going to use from time to time in the quant lab. But those are the basic ones. I mean, I may ask you for some oddball ones along the way. And as you move forward into dynamics, you're going to learn other things like mole fraction and molality and things like that, but we don't need those so much in the quant lab. We're kind of lucky here. Our definitions tend to be fairly simple, and we end up using the same concentration units over and over again. All right, any questions about those, guys? And one thing I'm going to be asking you to do from time to time is going to be able to essentially be able to go between those concentration units. In other words, can you take a molarity and convert it into parts per million if, for example, you know the density of the solution, or back and forth like that. And I think, as a matter of fact, I have one of those on my first homework assignment for you guys to practice with. All right. Now, that said, what we next need to think about is actually how we make solutions. And again, this is something you guys already know a little bit about. But it's something you're going to have to do in lab from time to time. So what if I had a situation where I wanted you to make up a solution, say, from a solid, and I want you to make it up to a particular molarity and volume, okay? Would you know how to do that? So, I mean, the typical situation might be something like this. I might ask you to prep a 0.150 molar big M solution of sodium chloride in a 500 milliliter volumetric flask. All right. So the question is, how would you go about doing that? Okay. So the first thing you'd have to do, obviously, is find a volumetric flask. And everybody knows what a volumetric flask is, right? You want me to draw one here just in case? I can do that. So a vol flask is one of those ones that has a real long neck associated with it, and then it kind of flares out at the bottom like this. Everybody used one of those before? Then you'll find somewhere on the neck of it, there's a little etched mark that looks something like that. Okay. Does that kind of look familiar to you guys? Did you use one of those last semester?
Yeah.
Bet you did. Okay. And generally, it's going to have a specific volume associated with it. So it'll state the volume on it. So this one will be probably stated as 500 milliliters. And then you kind of have to know the precision of the piece of glassware too. And that's another thing that you guys have probably talked about in lab before. And there's actually a lot of good information in the Harris text about this. But it turns out that a 500 mil volumetric flask is actually accurate to the nearest tenths place. Okay, so you can get 4 sig figs out of this measurement. And that's if you actually fill the volumetric flask just to the mark, so the meniscus just touches the mark. Okay, and you guys, again, made solutions like this before. All right, so I want to prep a 0.150 molar solution of sodium chloride in a 500 mil vol flask. So I go get my 500 mil vol flask, I go get to the stock room and get some sodium chloride, and obviously I'm going to need some distilled water. Okay. So the first thing I'm probably going to have to do is figure out, all right, how much sodium chloride am I going to need? All right, so sodium chloride's a solid, so it's something I can go to the analytical balance and I can weigh out. So that's probably what I would do. So I have to calculate how much of it I'm going to need to make this solution. So my given that I might start out with here would be 500.0 milliliters. That's the size of the flask. That's the volume I'm going to use. And I'm going to use the molarity. Now, you guys might remember back in bonding, molarity times volume gives you moles. You guys remember that? Molarity times volume gives you moles. Okay, so I got a volume there. Now I'm going to multiply by a molarity. Now watch how I do this. All right, that's going to be 0.150 moles of NaCl. Okay, I'm going to write that now. We know it's per liter of solution, right? But I also know that a liter of solution has 1,000 milliliters in it. So I'm just going to make that conversion right down here so I don't have to do it in a separate step. Everybody see how that's 1 liter? Okay, so mils now will cancel with mils. So volume times molarity gives me moles of NaCl. That's what the units are telling me. Oh, but I don't want moles, I want grams. But now it's easy. If I got moles by itself, all I have to do is use the molar mass or the formula weight, right? So I can go look that up. I know that 1 mole of NaCl, or I could calculate it from a periodic table, is 58.443 grams of NaCl. Okay. So now I can work this out. And it looks like I'm going to be good to how many sig figs here based on what I've got written in front of me?
Looks like 3.
Yeah, I'd agree with you. It looks like 3 sig figs. So I'm going to get to 3 sig figs, 4.38 grams of NaCl. Good. Okay. Oop, I need my grams there, don't I? Yep. So I'm going to go to my balance and I'm going to weigh out 4.38 grams. Now, if I use a 4-place balance, I'm going to get 2 places beyond that. Okay, so that's actually more sig figs than I'm going to need, but I would report that mass when I go back to calculate my actual molarity. But that's what I have to actually go get. All right, so let's say I've weighed out my 4.38 grams of sodium chloride. What do I do next? I probably weighed it into a weighing boat or onto a weighing paper, right? So what am I going to do next with it?
Would you just dissolve it into the solvent?
Yes, eventually. But the first thing I would do is I would very carefully get it into the volumetric flask, right? So I got a dry vol flask, or maybe I've rinsed it with water a few times or something. But I basically got an empty vol flask. So I'm going to very carefully pour that 4.38 grams of sodium chloride into the vol flask. Now here's a step that a lot of students forget. Now, if I use, say, a weighing boat or a weighing paper to do this, I might have left a little back on the paper. So what am I going to do to get it all in there? We want to be quantitative about this. What if there's a little bit hanging back? What do I do?
Use a spatula?
Well, you could, but there's an easier way.
Could you reweigh it, then subtract that amount?
You could, but again, that would be more of a pain in the arse than it's worth.
Would you rinse it with water?
Bingo. Yeah, just rinse it in. So you're going to have a squirt bottle with distilled water. So you would just take your weighing boat, kind of make it up into a little funnel and just kind of squirt water down into the vol flask. That's going to rinse anything that's left behind into the vol flask, right? So that's good. You want to be quantitative about all these things. So now we can be sure that the full amount of the sodium chloride that we weighed out is now sitting in the vol flask, maybe with a little bit of water around it, and that's fine. Okay, so what do we do next? Somebody mentioned, oh yeah, we want to dissolve it up in the vol flask, right? So that means I got to add some water. How much water do you think I should add?
Would you add, if it's a volumetric flask, would you add just enough or not to fill like the large bulb at the bottom? Because otherwise it would be really hard to dissolve it.
Yeah, that's exactly right. Yeah, you don't want to fill it all the way up because it gets really, really hard to dissolve up the solid. So I'd maybe fill it maybe a third to halfway. Okay, so then I can take that vol flask and swirl it around and the liquid will move around in there, right? And NaCl is pretty soluble, so it's going to go in nice and fast and eventually it's going to be all dissolved up. Okay, so now I've got it dissolved in there and I've got a flask about half full. So what's next?
Fill it up to the line.
Yeah, I'm going to fill it to the mark. Okay, so I want the meniscus to just touch the mark. So just to give you sort of a better view of that, here's the mark. And I want to fill it just to the point where the meniscus, which we get due to surface tension of the liquid climbing up the walls of the stem of the flask there, the meniscus is just touching that mark. So when I've done that, I know I've got exactly 500.0 milliliters of total solution in there. Okay, now am I done at this point? Is there anything else I need to do?
You invert the flask or put your thumb or cover the top of the flask and then invert it to mix it.
Yeah, because you got a concentration gradient at this point. You've got to assume, since you really haven't mixed it up, that you've got a concentration gradient there. So you're going to have a low concentration up in the neck of the flask and a high concentration at the bottom of the flask. So we got to make sure we mix it up well, invert it. So you're right. What we're going to do is we're probably going to take some parafilm or a cap. I prefer parafilm myself. And cap off or parafilm off the top of the flask. And I kind of put my thumb over it just to make sure nothing comes out. And I'm going to invert it a good 20 times. Okay, some people say 50, but I generally find 20 to 25 is fine. And I make sure that, of course, the liquid moves from bottom to top, top to bottom with each inversion. Okay, and that's going to carefully mix everything. Now, here's what ends up happening. You'll get to the point after mixing where now your mark is here, but you might notice that your meniscus is down there. Okay. Should you do anything about that?
I don't think so, because if you would add more, then your concentration would be lower.
Exactly. You're diluting if you add more water, because presumably maybe you lost a tiny bit through the parafilm, or maybe some is actually collected up in the nether regions of the stem up there. Okay, you might see some droplets collected up there. So all the solution is basically in there. It's just not collected back down. So yeah, you don't do anything here. Some students are sometimes like to say, oh, I need to add a little bit more water to bring it back. No, you don't want to do that. You've already accounted for your total volume. So even if after inversion, your meniscus has moved a little bit, don't worry about it. Okay, leave it right where it is. Now at this point, you're ready to go. You're ready to either leave the solution in the vol flask, or more than likely you're going to dispense it into some other receptacle, such as a dry beaker or an Erlenmeyer or a burette or something like that. Okay, so now you're ready to go. All right, any questions about that, guys?
For liquids with lower surface tensions, is it not a significant difference, the amount it sticks to the wall for the meniscus?
Yeah, the rule is the same. It's just that you're not going to actually see anything crawling up the meniscus in a case like that. So if you use like ethanol or something, which maybe doesn't have as high a surface tension, there'll still be a meniscus there, but it'll be a flatter meniscus. But the rule is still the same. Good question. And you actually won't run into that, because I think for the most part, we're generally going to be using solutions where water is going to be the solvent. Although I can think of a situation where we will be looking at solutions of ethanol and water. Good question, though. Any others, guys?
For one, are you not picky with converting directly milliliters to, or milliliters going directly without converting milliliters to liters, and then molarity from liters?
Yeah, like I did it there. I noticed I didn't go through the milliliter to liter conversion. I just kind of did it in one fell swoop. If you want to put the milliliter to liter conversion in, I'm fine with that. But if you want to skip it and recognize that liter is 1,000 milliliters, I'm fine with that too. And I'll show you other shortcuts that we're going to use as we move along as well. But that's totally up to you in terms of what your comfort level is. My normal nebulous sort of answer. So what, if you do want to do what I did there, perfectly fine. I would have no issues with that. All right, so just things to think about. Like I said, the homework is posted over at D2L, so you're welcome to go have a look at that. And if you want to get started on that, you can at least do the first problem, because I think it's just a units conversion regarding, I think, molarity to ppm, or one way or the other. So you can start on those if you want. And keep in mind, we're going to meet tomorrow in lab at 5 o'clock. I will have all the personal protective gear in terms of face shields. Same rules as last semester. You need to have eye protection, and you need to have a face mask. And we're going to provide face shields for you. So those are going to be the 3 things you're always going to have on in the lab: face shield, eye protection, and a mask. So make sure you come with 2 of the 3 of those things, and I'll provide the other. Other than that, there won't be a quiz tomorrow or anything like that. We're just coming to check in and kind of go over what we need to go over regarding the lab to get us ready for the next week. Anything else I missed there, guys? I think I got it all, and we should be about 20 after, so it's probably time to knock off if there are no other questions. Everybody good?
Last semester, if we had glasses, he didn't make us wear goggles on the face shields. Is it the same, or should we wear the goggles too?
It's the same. I wear glasses, and I'll just put the face shield on over my glasses. So just as long as you got something over your eyes under the face shield, you're good.
All right, thank you.
Yep, good question. Any others? Okay, so I'll see you guys all tomorrow, and then of course, lecture-wise, we'll just pick up here on Wednesday at 3:30. Okay, guys, I will see you tomorrow at 5. Looking forward to it.